All right, guys, we are rolling in hot on another press brake install. This time we're up in Oneida, South Dakota. And we're rolling in hot because we gotta melt this snow. So I'm up here at the Scott Farms. Really cool place. Kind of reminds me of being back in, you know, the guys over at the Gin in North Carolina that you've seen videos on. So that is the old homestead place here, family farm. Now the brothers run it, and the brothers grew up in there, and then that's where I stayed last night. So let's get in here and show you a little bit about what's going on in the farm. Looks just a tiny bit open, which is what we were going for. Let's see what you get there. Beautiful.
Close enough for me.
You know, like 0.1 degree over. Send it back. Trade it in. So what you're looking at is the second bend force 8-foot 145 ton press brake that I sold. And what we're doing here is just going through some basic, you know, dialing in and getting an understanding of, you know, a desired angle versus the corrected angle, and just kind of working through that process on some different materials.
Like it barely kissed it.
And what you saw there is just a little bit of a little test hit, you know, where it just comes down and barely kisses the material to make sure that you're everything's set up with the right tooling, and you know you're going to produce a right bend if you do that test hit first at 180 degrees. See there how open that is?
Never trust it.
Mm-hmm. 100 degrees, 99. Oh. Yep, that's more closed. Oh, it's more open, isn't it?
Mm-hmm.
So we were getting thrown off a little bit here with this flat bar, and in case you don't know, flat bar is a different animal than a piece of you know, metal cut out of a A36 hot rolled sheet. It's got thicker mill scale on it. It's, you know, I've never tested it, but it seems like it's a harder material, and press brakes definitely will react differently with it. So we were kind of just working through that. Looking pretty close. Still a touch open, but we know what we're doing here, so.
We do?
Kinda. 92, okay. Once you got this, no guessing, no correction needed. So that's John Scott there, one of the Scott brothers that I mentioned earlier, and then with him is Brody. It just, as it turned out, Brody is lives just like 30 miles away, and also purchased a brake around the same time that the Scott brothers got their brake. Brody ended up with a smaller 2-axis brake, and you know, we just kind of been working with him as well on supporting him through getting up and going on that. Well, this is my job, and I've gone the wrong way at least 3 times here telling you what to do. So we'll give you a pass. That's passing the eye test. Might still be a half a degree or something open. What you got?
Half a degree.
Yeah.
Pretty good eyes.
Just doing a little quick pan around of the shop here at Scott Farms in South Dakota, wrapping up this press brake install. Thought you guys might like to see their facility. And yeah, South Dakota in the winter, stuff on the ground. They got an easy sander, belt sander, and of course they got the Star Lab plasma table, and then your press brake that we put in.
Well, of course.
And check out this sweet milling machine here. 50 taper spindle, 10 horsepower motor. It is a beast, and it's in excellent condition. This was never a production machine, a worn out dog. This was well taken care of in probably a tool room or something like that. They got another Bridgeport over there. And this is pretty cool. They got a big wall of stickers, and they asked me to bring one, and dang it, I forgot. But I'll probably be back up here at some point with another machine. But this is pretty cool. A little small tool room area with a little CNC mill, Precision Matthews lathe over there, and a little CO2 laser that they imported themselves. And obviously, you can tell their political leanings, and I'm guessing that it's similar to most of you watching this channel, and me as well.
Oily. Yeah.
So here I was just showing this little device that detects phase rotation, and it was kind of acting weird, you know. If you had it in the correct position, which is right here, you see the amber light comes on, which indicates that something's wrong. But in the control, it was saying we had it the correct way. So I tried to get an answer on that for these guys, and I never got a straight answer why it was acting strange like that. So here you see John just working on the 2D on-screen drawing. So you literally can draw a part out, you know, a profile on the screen, and then set all your angles and dimensions. And this controller will convert that over into a bendable program. So we were just kind of, you know, playing with that and demonstrating it, and, you know, working through that process.
So what's it saying? Material. So where is it? Where it says the order.
Right there.
So, should we have it figured out? 20.
You're good. Go ahead.
CNC stuff, or the plasma table and the fiber laser. What program did you typically like to do your drawing on?
So if you notice the screen that's up there while the bend program is going on, it's showing you each step, you know, which way you should orient the part. And it's pretty helpful, you know. Sometimes it can, a part with a bunch of different flanges on it and returns and so forth, it may get a little confusing which order you should go in. And if you get the thing out of order, well, your part's no good. Definitely good to have that takeaway that you got in there on that.
Did that hold it long enough?
No, it's just got the opening height programmed to be lower. Let me get a close-up of this clearance.
Way off.
Got something wrong there. So where we messed up on that part on bending it is this thing, you know, the back gauge fingers give you this little ledge. So as the part gets deeper, you can rest it against the ledge and not the front. So you got support there. So it'll adjust the back gauge down, and we didn't catch that. So in the bend simulation, you can see it's still on the front of it there, all the way even there and there. But that one, we just changed it a second ago off camera, but you see how it's got it right there. So it let it go, let one leg go deeper than the other. So that was the mistake, but you can just change it right here to where you want it to catch on the back gauge. So if you're interested in any of these brakes and want to check out my website, it's bendforcebrakes.com. And on the site, you'll see pretty quickly, we have it broken down into the Precision Series and Fabricator Series brakes. So if you go into the Precision Series, you can see over on the right here, we've got the different prices and the payments for those. These are estimated payments, you know, based on a down payment, things like that. And if you know, a little bit more information about the machine, and then if you're interested in financing and the payments, you can go here to the Learn About, and then you can call this number and get qualified. This is Stearns Bank, who I'm partnered with, or you can just click the Apply Now button and go right into the application to see if you qualify and what size brake you would qualify for. So bendforcebrakes.com if you want to check that out. So I mentioned about the press brake calculator on the Cincinnati website. Now they actually have an app you can put on your phone here. So, but if you want to just use it on a computer, it's super simple. Let me show you real quick. So right here, you just select the material you want. Right here, you select your die opening. So for mild steel and thicker material, you want to use 8 times the material thickness. So let's just say we want to bend 1/4 inch. So we're going to do 8 times 1/4 inch is a 2-inch die opening. You know, you can select the grade here if you want. Mild steel obviously doesn't have any subgrades. So the bending length on a press brake is always how wide your part is. Let's say 24 inches wide, and then how thick is the material, so 0.25. And then right here, calculate it. You need 30.6 tons to bend that. All right, guys, we're back in Texas, and you can see we got press brakes. We got all the covers up there for the press brakes. And over here in the old shop, it's kind of dark in here. We still don't have power in here, but we got press brakes in here. So basically, everything on the Bendforce site is in stock as of now, except for the 4-foot fabricator. And those are about 4 weeks away, 4 or 5 weeks away. But I wanted to just expand on something real quick about these. So, you know, this is a 5-foot fabricator brake. It's 5 foot 70 ton. So, you know, if you want to get really technical about it, you can measure this thing out here. And it should be like right at 63 inches. So it's a little over 5 feet. But basically, if you take the 70 tons and divide it by the 5 feet, you're going to get 14 tons per foot. If you want to know what you can bend with this brake, the previous clip where I showed you on the Cincinnati website, you can put in your materials that you want to bend, put in the die that you plan to use, and if you're at 15 tons per foot or less, this brake will bend it, okay? It's as simple as that. You don't need to ask me what this brake is rated for. It's 15 tons per foot. It's simple math. And look, I know a lot of you have never had a press brake. You don't, probably understand this. But if you go, looking around at press brakes, you'll almost never see one with a rating of what it can bend. It's assuming that the operator is going to keep it within the safe limits. So hopefully you understand that, and that helps you out.